by boiling. By simple boiling, we can remove this type of hardness from the water. This hardness is also called as hardness because this hardness is due to the presence of bicarbonates of calcium and magnesium. So it is also called as carbonate hardness. Second type of hardness is permanent hardness. This hardness is due to the presence of chlorides and sulfates of calcium and magnesium dissolved in the water. And this type of hardness cannot be removed by simply boiling the water. And because this is due to the presence of sulfates and calcium of magnesium, not because of the carbonates or bicarbonates of calcium and magnesium, so it is called as non-carbonate hardness. Now, see, the process of removal of hardness is very important because for bathing purposes, for cleaning purposes, and for other purposes, we need soft water. So it is very important to make the water soft. The process of removal of hardness from the water is called as softening of water. Now we will see how we can remove the temporary hardness and permanent hardness of the water as we have done in the next previous video also. You can go there and can see that video if you have not seen that. First, I'll tell you how we can remove the temporary hardness. So, temporary hardness of water is due to the presence of bicarbonates of calcium and magnesium, and we can remove it by two methods. One of the method is simply boil the water by boiling. Okay, so the temporary hardness of water can be removed by boiling the hard water in large boilers. During boiling, the bicarbonates of calcium and magnesium decompose into soluble carbonates and give carbon dioxide. The insoluble carbonates, with this is that calcium carbonate and magnesium carbonate, these will settle down in the form of precipitate, and we can easily filter these impurities from the water, and water can become soft. Okay. Second method to remove the temporary hardness is Clark method. And this is also called as a calcium hydroxide method. Why it is called as calcium hydroxide method? Because in this process, we add the calculated amount of lime, where that is calcium hydroxide, the solution of calcium hydroxide we add in the water which is having the temporary hardness, and the soluble bicarbonates present in the water will convert into insoluble carbonates which settle down at the bottom of the tank and can be removed by the filtration. Here you can see these are the soluble impurities, calcium bicarbonates and magnesium bicarbonates. But when we will add calcium hydroxide, which is lime water, in the hard water, so what will happen? The precipitate of calcium carbonate and magnesium hydroxide and calcium carbonate will form. So what will happen? These will settle down in the form of precipitate, and we can easily filter these impurities. In this method, excess of lime should not be added. Otherwise, water can become hard due to the absorption of carbon dioxide from the atmosphere. Again, clear what will happen if the calcium hydroxide, this if we will add more amount of calcium hydroxide, then the remaining amount of calcium hydroxide will react with carbon dioxide. Carbon dioxide is present in the atmosphere and will form calcium bicarbonate again. So that is why I have said you that in this process calculated amount of lime water need to be added. Okay, so these are two methods by which we can remove the temporary hardness from the water. That is by boiling and by calcium hydroxide method. The another name is Clark's method. In boiling, we will simply boil the water, and in Clark method, we will add calcium hydroxide. In both these methods, the soluble impurities of calcium bicarbonate and magnesium bicarbonate will convert into the insoluble calcium carbonate, and this will settle down in the form of precipitate, and we can filter that impurities very easily. Now we will see how we can remove the permanent hardness of the water. So permanent hardness cannot be removed by the boiling. Okay, So it can be removed by these methods, that is lime soda process or zeolite process, which is also called as permuted process, and ion exchange process. So one by one, we will see all these methods. Okay, because as I've told you that water used for industrial purposes should be sufficiently pure. It should be free from hardness. Okay, so that is why it is very important to soft the water by any of these methods. We will see what are the advantages and disadvantages also of all these methods. So first method is lime soda process, which we have used in temporary permanent that hardness. In temporary hardness, I have said you that calcium, we can add the lime water in the calcium hydroxide, lime water in calcium bicarbonate, added water, and it will convert into calcium carbonate. Now, what will happen when we will add this here? See, this is a permanent hardness. Permanent hardness can be due to the presence of the chloride and sulfate salts of magnesium and calcium. If we will add lime water in magnesium chloride or magnesium sulfate, so it will remove the hardness of magnesium, but here in the water there will be the hardness due to the presence of calcium chloride. It will form calcium chloride. When magnesium chloride will react with calcium hydroxide, it will convert into calcium hydroxide, yes, which is a precipitate, which will settle down in the form of precipitate. But here the another product is calcium chloride and calcium sulfate. So lime water can remove the hardness of magnesium, but it cannot remove the hardness of calcium. So what we will do to remove the permanent hardness from the water, we will add washing soda. So the first method is by using washing soda method. In this method, water we can treat with a calculated amount of washing soda, which is sodium carbonate, Na2CO3. The exact formula of washing soda is Na2CO3 dot 10H2O, but here we will write only Na2CO3, because here we are taking water which is already in the liquid form. So when we will add that sodium carbonate or washing soda in calcium chloride or in magnesium sulfate, so what will happen? It will convert into calcium carbonate or magnesium chloride. You can see here in the reaction, and calcium chloride and calcium carbonate and magnesium carbonate, both these will settle down in the form of PPTs. That is, these will settle down, these will precipitate, and we can filter these impurities. The other product you can see here is here are sodium salt, that is sodium chloride and sodium sulfate. So sodium chloride and sodium sulfate do not cause any kind of hardness in the water. The hardness is due to the presence of calcium and magnesium salt, and that can be easily removed by adding washing soda in that. So this is the first method by which we can make the water soft. Second method is, first we will see the advantages and disadvantages of lime soda process. Advantages is that it is very economical, okay, and if the process is combined with sedimentation or a coagulation, then lesser amount of coagulants shall be needed, and then the process increases the pH of the treated water, thereby corrosion reduces. Okay, then in addition of the removal of hardness, the qualities of minerals in the water are reduced, because when we are removing the hardness, the some minerals will also get removed by this process. So due to alkaline nature of treated water, amount of pathogenic bacterium in water is considerably reduced. So these all are advantages of lime soda process. But what are the disadvantages? For efficient and economical softening, careful operation and skilled supervision is required. Otherwise, the amount of lime or soda can be more, and our problem will not get solved. Disposal of large amount of sludge poses a problem, because these calcium carbonates and magnesium carbonates will settle down in the form of PPT, so these will produce the sludge. So this is again a problem, that we need to remove this sludge also from the water, and by this water, uh, this can remove hardness up to 15 ppm only, which is not good for boilers. Okay, boilers mein kya hoga, this will settle down, this will settle at the boilers, and boiler can get corroded due to this. So we can say that this is not a very good method. So the next method is zeolite or permuted method. What is this now? There are